All right, let's go ahead and take a look at 7.5. In 7.5, we're dealing with the magnitude of the equilibrium constant. And so this is going to bring up a concept or a point that we have raised before, which has a lot to do with the value of k. And so we had indicated before that there were a couple of outcomes for k, and we had learned or had discussed previously that k could be a couple of values here. So we've learned that k could be equal to 1, k could be less than 1, or k can be greater than 1. Now, the one that kind of shows us here greater importance or significantly more importance, no pun intended, is going to be the value here where k is greater than 1. What we're saying here is that the concentration of the products is significantly greater than that of the reactants. And so this kind of reaction, whichever reaction it may be that has this particular k value, it means that the products are strongly favored. So the bigger the value of k, the more strongly those products are going to be favored. So we have to consider a couple of examples here where the value of k could be something like, let's say that you have a value of k is equal to, just for numbers here, 2.1 times 10 to the negative 11. This particular value, even though there is a little bit of product being formed, the value up here, the negative 11, essentially tells you that it's mostly going to be in the reactant side of things, because this value here, 2.1 times 10 to the negative 11, is actually a pretty small number. So if I actually convert this out to decimal form, you'll see this a lot easier. So let me go ahead and do that now. So here is the number converted into decimal form, but notice how far away we are from 1. This number is a very, very small number. So if this is the value associated with k for any given reaction, yes, the reaction is going to proceed, but it's going to proceed in the forward direction to produce products at a very small, tiny fraction of an amount. Whereas if we have another value, let me move this slightly over to the left over here, as opposed to, let's say that we had a value that was roughly k is equal to 2.1 times 10 to the, say, negative 2. Even though we have a negative exponent here, when we convert this value here, so it's 2, 1, there's 1, 2, you can see that this particular value here, 0.02, is significantly greater in amount compared to the one on the left. So this one here, the one with the expression in yellow, this particular reaction is going to strongly favor, compared to the one on the left, it's going to favor more product formation. However, keep that in focus and in context here. It's still a small number, so we're still on the reactant side of things, but we are going to produce a significantly more amount of product when we compare it to the reaction with a k value of 2.1 times 10 to the negative 11. So the main thing that we need to be able to address in this section is to ensure that the value for k is going to essentially influence how much of a product we're going to get or whether a reaction goes to completion. K values with a very that are very large, closer to 1, are going to produce a significant amount more product, and so they're favored to go forward in the direction of product formation, so they go to completion more or get closer to that. Now, neither of these examples shows an example of going to completion. For that, let me go put another one down here at the bottom. And so an example of a reaction that goes down to completion would be something like k is equal to 2.1 times 10 to the 2. So notice here the exponent of 2. The coefficient, if we actually convert this into decimal form here, that's 2, 1. And so it's 210. It's arguable here demonstrably that 210 is 210 times greater than 1. So the reaction here at the very bottom that corresponds to this one here down at the bottom, this one goes to completion. And so that's what you want to be able to do at a glance when you look at some of these k values. So those are the main topics in 7.5, and so we'll see you in the next section.